going to finish chapter 16. So everything in chapter 16 so far has been a discrete random variable, which means we could create a probability model. We had the table, we had a specific set of outcomes and their probabilities associated. But now, with the problems we're going to do today, we don't have a list of those outcomes. Instead, we have continuous random variables that can take on any specific value. Luckily, all the rules we talked about yesterday all still apply, and we're going to be able to use normal models to help us find probabilities. Okay? So, the amount of cereal that can be poured into a small bowl varies with a mean of 1.5 ounces and a standard deviation of 0.3 ounces. So I'm going to go ahead and we can define the small bowl as X, mean of 1.5 ounces, standard deviation of 0.3 ounces. And a large bowl holds a mean of 2.5 ounces with a standard deviation of 0.4 ounces. So I'm just defining those and writing out the information so that I can use it in a second. You open a new box of cereal and pour one large and one small bowl. How much more cereal do you expect to be in the large bowl? And this is asking how much we expect. We're really looking at expected value, and we're trying to figure out how much more would be in the large bowl. So expected value of the large bowl minus the small bowl, right? So we have, when we do expected values, we can just subtract the expected values of the individuals. So we have 2.5 minus 1.5, so a difference of 1 ounce. And then B, it says, what's the standard deviation of this difference? So we're combining two variables, which means we have to use the variance. And then we have to find the standard deviation from that. So the variance here would be 0.3 squared. And even though it says subtract, there's always going to be more variability, so we add. Plus 0.4 squared, we get 0.25. So if I want to know the standard deviation of this difference, we take the square root. And so our standard deviation is 0.5 ounces. We could have done those probably yesterday with our rules. So here's the difference. Part C. If the difference follows a normal model, what's the probability that the small bowl contains more cereal than the large one? We haven't done normal models in a while. So first of all, let's just draw one. Remember, it's a bell curve. You need a mean and a standard deviation to be able to fill out a normal model. So the mean here is 1 ounce for this difference. And then we have a standard deviation of 1/2 an ounce. So we can have increments of 0.5. We could fill in, we could have the 68, 95, 99.7 rule if we wanted to. So here's my normal model. And it says, what's the probability that the small bowl contains more cereal? If we're doing the large bowl minus the small bowl, and we want the small bowl to have more cereal, then the difference has to be negative. If the small bowl is larger than the large bowl, then we have to have a negative difference. So I'm really only worried about what's happening below 0 in my normal model, all the negative values. Okay? So, again, haven't looked at normal models in a while. We can calculate that area using normal CDF, the cumulative density function in your calculator. It tells us what the probability of that happening is, or what that section is. So if you use your calculator, you go to second variables, the distribution menu, and use normal CDF. In this case, our lower bound is negative infinity. We're looking for the far left side. So negative infinity to 0, because we want all those possible negative amounts. And before, I always made you use z-scores. In this case, we've kind of moved beyond that. So I want you to be able to answer the question without having to calculate z-scores as well. So your mean is 1, and your standard deviation is 0.5. So you can actually input that into your calculator. And so it tells us the probability is 0.02. So a very small chance, a 2% chance that the small bowl contains more cereal than the large one. All right, so then the next set of questions follows the same pattern. What are the mean and standard deviation of the total amount of cereals in the two bowls? So in this case, I'm not subtracting the two bowls. I'm actually combining the two variables. I want to see the total. So the expected value, there was a mean of 1.5 for the small bowl, a mean of 2.5 for the large bowl. So we have a mean of 4 ounces when you combine the two bowls. And then again, if we're going to find the standard deviation, we can't combine standard deviations, but we can combine variances. If you combine the variances, it should be the same answer because you always add more variability. You're always adding variances. So I did y minus x before. So I had 0.3 squared plus 0.4 squared. Same thing here. You take the square root, you get the standard deviation. So the variance would be 0.25. Take the square root, we get 0.5 again, right? Because no matter if you're adding or subtracting those two, you're always adding variability, so you're always adding the variances. So that answers part D. And then E says, if the total follows a normal model, what's the probability you poured out more than 4.5 ounces in the two bowls together? So if we draw out another normal model, the sum of a mean of 4 ounces, but the standard deviation is still 0.5. And we want to know the probability that we poured out more than 4.5 ounces. So that's 4.5 and above. Then I can use normal CDF again to calculate how often that would happen. So normal CDF, this time we're going from 4.5 ounces to infinity. Those are our boundaries. With a mean of 4.5 and a standard deviation of 0.5. Jeez Louise. Sorry, my mean's 4. There we go. I knew it was supposed to be 50%. All right, so 16% chance. We could have answered that since it's on one of the hash marks here on the normal model. We could have answered that with a 68, 95, 99.7 rule as well. But we're just using things we've learned in the past, and we're applying them here to random variables. We could finish this question, but it's more of the same. It's just asking about the expected amount of cereal left in the box and the standard deviation left in the box if they give you the total amount from the box. So we could do more of those. I just wanted to see a few examples, though. The homework tonight will be the practice quiz, and then the 3 questions on page 385 are just like we just did here. So we're practicing with that whole finding means and standard deviations by combining random variables. It helps you practice with all of those different rules. And then also using the normal model to help you find probabilities or continuous random variables.